To meet the future needs of LEO, GEO and deep space missions, new technological approaches are vital. A group of European experts has designed a new electric space propulsion system for any space destination.
We are a group of experts developing the first European plug-and-play gridded ion engine system. Partners in the consortium are ArianeGroup and QinetiQ, which are responsible for the system and thruster engineering. Airbus Defence and Space being in charge of the development of the power processing unit, while advanced space technology experts are responsible for the electronic pressure regulator and the flow control unit. Another partner, Mars Space Limited, is supporting the consortium in the analytical design, whereas the University of Southampton is analyzing the use of alternative propellants, and the satellite prime OHB is in charge of the requirement specification.
The Giesepp project is supported by the biggest EU research and innovation programme ever. The European Union's Horizon 2020 Research and Innovation Programme. The project started in 2017. Since then, experts from 3 European countries have been working together on a space propulsion system which is highly efficient at lower costs.
So electric propulsion is a type of space propulsion which makes use of electrical power to accelerate the propellant and generate thrust. Compared to chemical propulsion, electric propulsion requires less mass to accelerate a spacecraft. The propellant is ejected up to 20 times faster than from a standard chemical thruster. Therefore, the overall system is more mass efficient. And this reduced consumption of propellant mass leads to lower emission costs. It can also allow embarking more experiments on satellites.
An electric propulsion system is composed of electrical thrusters. These are connected to their power processing units, to a propellant storage, and a feeding system which includes tanks, pressure regulators, flow control units and valves. The characteristic feature of gridded ion engines is that they utilize grids to extract ions from the plasma. The ions are then accelerated to high velocity. Gridded ion engines provide high acceleration and lifetime performance. That's what makes them one of the key technologies for future deep space exploration.
There are 2 types of gridded ion engines considered in Giesepp, and these are defined by the technique used to generate the plasma. So one uses the radio frequency technique proposed by ArianeGroup, and the other one uses the DC discharge technique proposed by QinetiQ. The main advantage of the gridded ion engine technology is that it offers a very high specific impulse compared to other electric propulsion technologies, and so this can offer a substantial mass saving. Another essential feature of the gridded ion engines is the high growth potential with increasing electrical power that could be available on the spacecraft.
The Giesepp team is working on 3 electric propulsion solutions for LEO, GEO and deep space missions. While 1G is developed for GEO applications and navigation requirements, 1L2L is developed for LEO platforms primarily, but can also perform station keeping in higher orbits. 1S is a clustered electric propulsion system solution. It offers variable operating scenarios and high reliability for exploration missions through full chain redundancy.
The solutions developed by Giesepp follow a modular approach with multiple options. For example, we offer an optional electronic pressure regulation, which means the integrator can choose to realize the regulation on its own.
Giesepp puts particular emphasis on cooperation. Experts from different fields and companies work together on a common goal: realizing a plug-and-play system based on the gridded ion engine technology.
An important aspect of the Giesepp system is that we definitely want to avoid a single-source situation for the customer. First of all, we have all the advantage that we can gather all experts in every respective technical field. With a particular situation in Giesepp that we, on the thruster level, we have the 2 main competitors in Europe with regard to gridded ion engines working together instead of working against one another, which gives us the possibility to set up a really optimized solution.
Thanks to Giesepp program, GRISA is developing a compatible PPU for two of the main players of gridded ion engines. Giesepp gives us the opportunity to work with really different types of companies, and this is a huge thing for the project because we all look to the same target.
Giesepp's gridded ion engine system will not only enable future space missions, but opens up new horizons.
The best part of the project is that we are able, across competitor borders, to discuss what are feasible technologies, what have to be improved, that we are competitive in the market.
You begin with an idea, but at the end it has changed a lot. And now I think we are close to the future than before.
Giesepp, highest efficiency in every mission.